Hi, I'm Papia. In this problem, we have to first find the limit of x squared minus 3 as x is approaching to 2. And then we have to find delta for some given epsilon values such that this statement is correct. Where the statement is absolute fx minus L less than epsilon whenever 0 less than absolute x minus c less than delta. I'll explain that in a minute. Let's find the limit first. So notice that this is a polynomial. There is no denominator, no square root, so you can just directly substitute and you will be able to find the limit. So let's do that. Directly substitute x equals 2 and the limit will be 2 squared minus 3. So 4 minus 3, which is 1. So this is the limit. Now, let's see what this next statement means. Okay, let's see. We have the function f of x is this function, x squared minus 3. L is the limit, and we just found it, so the limit is 1. So L is 1. Epsilon, they're given to us. For this next inequality, x is just the variable x. C is where x is approaching to. So C is 2. And delta is what we don't know and we have to figure out. So for this given epsilon, for each one, we will find a delta. So this statement is basically the definition of limit existing. So what we're saying is, to quickly understand this, let's just look at a graph. So our function is x squared minus 3. No, looks something like this. It's a parabola. And we know that as x is approaching to 2, the function is approaching to 1. So, say 2 is somewhere here, and it's approaching to 1, somewhere here, all right? So, what is the concept of limit? The concept is as x is approaching to 2, so x is getting close and close to 2 from either side, the function is getting closer to this value 1. That's what it means. And that's exactly what is written here as the definition of that limit. In other words, this particular expression here is saying that when f of x is inside this interval L minus epsilon and L plus epsilon. And this particular statement says x is inside the interval c minus delta, c plus delta. So let's understand the interval notation in this picture. So we want to find what interval is there around 2 with a radius of delta. So c minus delta, c plus delta, that's 2 minus delta and 2 plus delta. So what is that delta length? So when x lies in here, f of x will lie inside an epsilon interval of 1. So 1 plus epsilon, 1 minus epsilon. That's what it says. Because you understand that as x is getting close to 2, fx will get close to 1. So if we reduce this neighborhood here, this neighborhood has to be reduced as well, right? So we have to figure out, given this epsilon, so this is given to us, this length, what should delta be so that this statement is correct? That's what we're trying to find here. Okay, so to solve this problem, we actually kind of go backward. And I'll tell you what that means. So let me write this statement down one more time. We have to find delta such that whenever we have this situation, 0 is less than x minus c, c is 2, less than delta, this is the guy we don't know, then we will get this particular statement, that is f of x is x squared minus 3, minus L is 1, less than epsilon, where epsilon has various values, which we will deal with later. So let's just find delta for any given epsilon. Okay, so we have to find delta one more time. What is delta? So that this is happening. So to solve a problem like this, we actually have to go backward, because we have to start here and we have to find an expression like this. So let's start with this expression here. Okay, we have absolute x squared minus 3 minus 1. Let's work with that and manipulate that a little bit. This is equal to x squared minus 4. Okay, notice that we need to get absolute x minus 2 from here. Do we have it? Of course we do. See, it's the difference of two squares, x squared minus 2 squared. If you break it apart, it becomes x minus 2 times x plus 2. Okay, now we can split it into two different absolute values. So this is absolute x minus 2 times absolute x plus 2. Okay, so we want this to be less than epsilon. Figure out what will delta be. So absolute x minus 2, we don't have to do anything with it. We want that on the left side, and we have it. But this is an extra piece. So we have to find an upper bound for absolute x plus 2. How to do that? Well, notice that one more time, x is getting close to 2. So we can say that let's fix the interval around 2 to be 1 to 3. So let x be in the interval 1, 3. That's an interval around 2. Well, we probably have to make it even smaller interval. So let's assume that. When we assume that, notice that this is possible if we make delta to be less than 1, right? Because 2 is in the center, we are assuming 1 to 3, so delta is less than 1. So that's a value of delta that we have to consider. Okay, so if x is inside this interval, then what happens to this quantity x plus 2? Well, x plus 2 cannot be more than 3 plus 2, right? Cannot be more than 5. This is what we want. We want to replace this particular expression with a number, with an upper bound, and we have it right here. So let's see. We have absolute x minus 2 times absolute x plus 2 is then less than, this is 5 times x minus 2. And this quantity is less than epsilon. So solve for absolute x minus 2 is less than epsilon divided by 5. Look, absolute x minus 2 less than delta, absolute x minus 2 less than epsilon over 5. This is delta right here. But remember, we also had another factor here, right? Delta is less than 1. So what is really delta? Delta will be minimum of these two values, 1 and epsilon over 5. Okay, so given these two epsilons, we have to figure out what is delta. So delta is minimum of 1 and 0.01 divided by 5. Well, 0.01 divided by 5 is just 0.002. So minimum of these two values is, of course, this one. So in the first case, delta is 0.002. For second case, again, this is minimum of 1 and epsilon is 0.005 divided by 5. And the second quantity is just 0.001, and the minimum of the two is 0.001. So we have the two different deltas for two different epsilon. So before we finish the problem, let's go back and let's try to understand one more time what we really did here, what this work really led to. So in case you're confused and you're thinking, why did we start with this expression x squared minus 3 minus 1? Because we had to go this direction, right? When this is happening, you have to show this is happening. But the reason we start on the right hand side is because epsilon is always given to us. Delta is what we have to find. So the idea is you start with what is given and work backward to have a guess or an idea what could delta be, and then you look forward. That's what we did here. So let me explain one more time here. You remember we started with the expression fx minus L. This is the function and this is the L. And we simplified it and we got x minus 2 and x plus 2. Now, usually we always want to find the expression x minus c from fx minus L. If the limit exists, you will be able to find this expression, okay? Now, the problem was it wasn't just x minus c, but we also had another extra piece. And we had to find a number corresponding to that one so that we only are left with x minus 2. And then whatever number we have in the right-hand side of that, we will be able to say that's our delta. So if you're confused, I want to show you how the forward direction works. Okay, hopefully that will clear it up. So let's see. Remember, so this is our expression, right here. And we actually evaluated what the number will be for x plus 2, which I will also explain why we got that number. And using that, we found something here. Okay, so I want you to look in a forward direction. Okay, so suppose x minus 2 is less than delta. Okay, if that happens, and delta, remember delta was epsilon over 5? Okay, so we found delta to be that. If that happens, and we also have this extra piece, x plus 2 is less than 5. Notice what happens when you make the product. The product is x squared minus 3 minus 1, right? That is this part. That will be less than, multiply this two, epsilon over 5 times 5, and that's epsilon. So it gives us the right hand side. So we worked backward, but then the forward direction works as well. Okay, so one more time, whenever you have to find delta given an epsilon, you start with the expression that has the epsilon, and from the function, from that fx minus L, you extract x minus c. And the remaining portion, you find an upper bound, because this is what's going to happen. That upper bound times whatever the delta is will cancel out and will give you epsilon. Okay, now here to find that upper bound, we also made an assumption here that suppose we consider x is already inside the interval 1 to 3. Notice that this is arbitrary. You can change that. Okay, you can make it bigger or smaller you want. And if you change that, this number will change, which means this expression for delta will also change, which is okay. Delta is not necessarily a fixed quantity for a given epsilon, because if this works for a certain delta, it will work if you make the delta smaller as well. Okay, so it's not fixed, but it is very standard to choose delta equals 1 because it's easy to handle. So that's why I chose that particular delta value here. Okay, and fix my interval to be just, 2 is the center, go from 1 to 3. But again, you can change that, and you should probably try it to see what different delta values you get. Hopefully this clears things up. Thank you.